Next, it's my honor to welcome our keynote speaker, David Keyes. David Keyes is the CEO and founder of R for the Rest of Us, and I think very importantly for our conference, is a longtime member of the R community and actually has been coming to our Cascadia since almost the beginning, so since 2018. And I think many of us, if you've searched for help online with some R problem, you've probably seen some of his work. So everyone, please welcome David Keyes.
Good morning, folks. Thank you so much for having me. As Cameron said, I have been coming to Cascadia R conference for a long time. This was actually the very first R conference that I ever attended when I first started getting into R, which was, I think, 2018 in this very room. So I'm excited to be here today and talk with you about doing things in R that you didn't know that you could do. 25 things to be precise. I find it kind of ironic, though, that I'm up here talking to you about unique ways to use R. And I say that because for a long time, I didn't really feel like I was a real R user. You see, I don't come from a typical R background. I'm a qualitative researcher by training. I have a PhD in anthropology. I don't have advanced training in statistics. The most complicated statistics I ever do when working in R is descriptive statistics. Eventually, though, as I continue to learn R, I realized that R isn't just about statistics, or more precisely, R can do more than complicated statistical techniques. And as I learned to use R for things like data visualization, reproducible reporting, making maps, R became like a Swiss Army knife for me, enabling me to do anything I needed to do with data. Eventually, I came to peace with how I use R. I realized that I don't need to do complicated statistics to be a real R user. And in fact, even among people who do use R for complicated statistical things, R's capabilities as a more general purpose tool are generally pretty appealing. So my goal today is to show you a few things that you can do with R in that area that you may have never considered. I'm going to talk about several categories of things: accessing data automatically, efficiently making beautiful data viz, making maps, reporting in new ways with Quarto, automation, using AI to write better code, and using AI to analyze your data. I have half an hour and I'm talking about 25 things, so I'm going to go pretty quick. If you go to this URL, rfortherestofus.com/Cascadia2025, all of the code samples that I'll show, as well as links to additional resources, will be available. So don't feel like you have to copy things down as I'm going. All right, let's talk about accessing data automatically. You've probably imported data from a CSV or an Excel file, but there are tons of other ways that you can access your data. One that I like to do a lot is to access data directly from Google Sheets. We at R for the Rest of Us do a training program where we bring in data from Google Sheets. We use the Google Sheets 4 package to bring that data in automatically. We do a survey. For some reason the survey part isn't showing, but the survey actually asks questions in a Google form. That data then goes to a Google Sheet, and then we can run code that looks something like this to bring it in. We load Google Sheets 4, we use the read sheet function to bring our data in. As a result, then we can quickly make charts to show, for example, how frequently people have used R, and we can run that each cohort and it automatically updates. Again, let me just refresh this and make sure. There we go. Okay. If you use Qualtrics, which is another tool for doing surveys, there is a package called Qualtrics with a capital R. That package can also allow you to very easily bring in data. You load the package, you run the fetch survey function with your survey ID that you can get from Qualtrics. Every time you rerun your code, you'll have the newest data, which is a huge time saver. As a social scientist, I also work a lot with census data. I need to bring in data from the Census Bureau. I used to spend hours and hours looking at screens like this from the Census Bureau website, finding the data that I needed, downloading it in Excel, working with it, then realizing, oh, I need something else, going back, downloading it. I can see a few nodding faces of people who have probably done something similar. Now I use a package called Tidy Census, which allows me to connect directly from R to the Census Bureau. I use it to make maps like this, which show, for example, the largest communities in Oregon. And the way I do it is I load tidy census. I'm using here a function called getACS, which is to get data from the American Community Survey. And this is actually bringing in data on the population of every single place in the state of Oregon. So you can see this is geospatial data. We've got the towns, and then the estimate is the populations. And that's how I make that map. Now, the Google Sheets 4 package, Qualtrics, and Tidy Census are all kind of wrapper packages around what are known as APIs, Application Programming Interfaces. They help you to connect directly to external data sources. But sometimes there is no wrapper package for a data source that you want to connect to. In that case, there is a package called Header2, which allows you to write that code to connect to the API. So for example, this is some lightly adapted code that I use to bring in data from a tool called Fathom Analytics, which I use for web analytics on the Art for the Rest of Us website. You can see I'm first setting my API key to authenticate. Then I'm using code from Header2, where I'm starting a request, setting some parameters in my URL query, setting some headers where I'm adding my API key, which you can see here. And then I'm performing that request. And when I do that, I end up with data that looks like this. I can do whatever I want with it at that point. In this case, I have an internal dashboard where I aggregate that data, and I can see the results of web traffic, and I can update it at any time. Now, if you don't have a wrapper package to access data and you don't have a way to connect directly to an API, you can also scrape data. There's a package called Arvest, which allows you to do this. Imagine, for example, you wanted to get this data. This is on a Wikipedia page on list of Men's World Cup finals. To do that, you could run library Arvest, and I've got library tidyverse as well. I'm running the read HTML function, running read_HTML, bringing in all the HTML from that one page. Then I'm using HTML elements to extract all the tables, pluck 4, because there are actually 4 tables on that page. Then I'm turning it from an HTML table into a tibble, and you can see that I end up with data that looks like this. Next section of things I want to talk about is efficiently making beautiful data viz. I'm going to talk less about how to make really good data viz and more about how to do it efficiently. So the first thing is to consider making your own ggplot theme. You've probably used existing themes like Theme Minimal, for example, but you can actually make your own. Here's a chart that I made that does not have any theme applied, right? Like you see that ugly gray background that everybody knows is the ggplot default. Well, if you want, you can make your own theme. So here's an example of a theme that I made called ThemeDK, which is just a function. It's got a base family of intertype, which is a font that I use a lot, and a base size. And you can see then within my function, I'm starting with theme minimal, and then I'm making a bunch of other tweaks using the theme function from ggplot. So now, if I run Penguin's bar chart and I add ThemeDK, I can get this, and I can make all of my charts look consistent. Now, when you make a theme, you probably want to apply it to all of your charts. There's a function called themeset from ggplot, which allows you to run it once, and then every chart you make after that will automatically have that theme applied to it. So that's a big time saver over, for example, making every single chart and adding plus ThemeDK. What you can do is in a Quarto document or at the top of an R script file, you run themeset, and then again, any chart will have that theme applied so that the chart at the bottom of that Quarto document would look like this with my theme applied. When you make a theme, that handles a lot of the text. For example, you saw that I changed the text to intertype, but that handles the text in things like axis titles, plot title, subtitle, that type of thing. What it doesn't do is it doesn't change anything with your text if you add it using like geom text. So for example, say I did this where I'm using my Penguin's bar chart, I'm using ThemeDK, I'm actually changing the base family to IBM Plex Mono just to make it a different font so it's really obvious. And then I'm going to add some text, right? So you see I've made my chart and I've added this text. Now, if you look closely, you'll see that most of the chart, like the title, for example, here is using that monospace font, IBM Plex Mono. But this font is not using that. Again, because it added it with a geom. So the way that most people deal with this is they'll add like family equals whatever in their geom text. And that works, but imagine you're making 20 different charts. It's kind of annoying to have to put that every single time you write geom text. So there's a function called update geom defaults. Very similar idea to theme set. When you update geom defaults, you specify the geom that you're targeting. In this case, I'm targeting the geom text. And then you set default aesthetic properties. So I'm saying family equals IBM Plex Mono. So after you run this, so you can see, for example, in a Quarto document, you could have that there. And then after you run that, just to show you, I don't have the family here. I don't know why that's not scrolling down. But even though I don't have that, you can see that my font now is that monospace font. All right, so we've talked about ggplot now for making charts. You can also make maps in ggplot. And the great thing about it is that everything that you know about ggplot for making charts applies to maps as well. So let me show you how you can make a map with ggplot. I'm bringing in data, again, using the tidy census package on median income by county. So it's going to give me data on every single county in the US. Scroll down a little bit. So you can see I've got the counties, and then I've got the estimate there, which is the population, or sorry, the median income. Then I've got some code here. So I'm taking my median income by county data, piping it into shift geometry, which you'll see in a second will just make Alaska, Hawaii, and Puerto Rico easier to see. And then from here, this is just ggplot code. There's a special geom called geom SF, which works with what's called simple features data, which is the type of geospatial data that's pretty much the standard. And you can see with those few lines of code, I can make a map. You can also do geospatial analysis. I'm not a GIS expert, but I've learned enough to be dangerous / useful. So I'm going to answer this question. Which elementary schools in Portland are within 1 mile of a public library? Okay, I'm doing this because I actually had a similar question that a client I was working with asked me. They work with what are called SNAP-Ed sites, which are kind of education for like nutrition education for folks who receive food stamps. They wanted to see which were within like 5 miles of a grocery store. I thought I'd come up with an example that's a little more local. So for doing geospatial analysis, the main package that you end up using is called SF. And so I'm going to load SF, and I'm going to read in data on Portland libraries using the read_SF function. I'm reading in data in a GeoJSON file. And this is what my data looks like when I bring it in. I can put that on a map, and you can see all of the libraries in Portland. Then, because I want to see which schools are within 1 mile of each of the libraries, I want to create a 1 mile buffer around each library. So I'm using the stBuffer function from the SF package, which creates a buffer around each library. And the 1609.34 is converting meters to 1 mile. And there you can see what I have. Now, I'm going to read in data on PPS, Portland Public Schools, elementary schools. So I've got all the elementary schools, and you can see those. To figure out which ones are within the 1 mile, I'm going to use the function stjoin from the SF package. So in the same way you do joins with like left join, full join, stjoin will help you to do a spatial join. So now you can see I've got data here, and it's got the school, and then it has whether or not there's a library within 1 mile. So you can see some of them do have a library, some of them don't. I've done a little bit of additional data wrangling just to create a new variable, as you can see here, called has nearby library. So my data ends up looking like this. School, whether it has a nearby library, and then the geometry column, which is what makes it geospatial. When I map it, you can see I end up something like that. So again, I'm not a GIS expert, but you can, with a little bit of code, you can learn to do some simple geospatial analysis. Now you might be wondering how I made those interactive maps that I just showed you. There are a lot of packages for making interactive maps. With R, Leaflet is probably the most common. The one that I use, and the one I have really grown to like is called MapGL. It's made by Kyle Walker, who's the same person who makes the Tidy Census package. With MapGL, you run library MapGL, and then there are different functions to make maps. I'm using one called MapLibre, and I'm specifying the bounds so that my map ends up focusing on Portland. If I didn't put those bounds, it would just be a map of the entire globe. Then you can add layers, kind of in the same way you do with ggplot. So I'm adding a fill layer, which is Portland Library's 1 mile buffer, and we get that. Next, I'm adding a circle layer. So you can see I'm adding all of this. I'm also changing the colors here. So you can see I end up with my schools on the map. And finally, I'm adding a legend. So I'm using the add categorical legend function, and I end up with my legend up here in the top left. Put that all together, add my fill layer, my circle layer, and my categorical legend, and we end up with that. All right, so we've talked about a bunch of different things. Let's move on now to talking about reporting in new ways with Quarto. When I teach people, I typically start out with pretty simple output formats, right? Like an HTML document, maybe a PDF, Word document. But there are a lot of different things you can do, and you can make many different outputs with Quarto. So if I make a Quarto document, here, a median income report, I basically did what I showed you before, but I added some code that actually brings in the data for Oregon and makes the map to show median income. And you can actually switch your output format really easily to make slides. So this, I switched it to format reveal.js, and you can see now it's broken up my content into slides. Not to be too meta, but you're actually looking at a slide presentation embedded within another slide presentation, because my slides that you're actually seeing displayed are made with reveal.js as well. And then I've embedded another reveal.js slide presentation within that, but that's not super relevant. You can also make an entire website. So when you make a website, you're typically going to have more than one file. So you might have like an index file, index.qmd. You have maybe an about file, and then you have an _quarto.yaml file. So the _quarto.yaml file is what really like ties together your multiple Quarto documents. So here I'm specifying project type equals website. I'm saying the title for the website is median income website. I'm specifying the nav bar, which should show up on the left side and have those two things. And then I've got format HTML. I do that in my _quarto.yaml. I add the format HTML. You don't have to then put it in each file because this applies to all of your Quarto documents. And when I do that, you can see how I've now made an entire website. Now, when you make any kind of output in Quarto, it's nice if you can actually follow the branding of the organization that you work with. Until recently, this has been relatively complicated, but the team at Posit has been working on a new tool called brand.yaml, which aims to simplify the process of ensuring everything you make is on brand. With brand.yaml, you create an _brand.yaml file, and you add it into your project next, like in the same location as your Quarto document, and your Quarto document will automatically take those styles. So I've created a very simple version of it here where I'm specifying these are some colors that I'm going to use. These are my brand colors. You'll see it's a light blue and a dark blue. I'm specifying the fonts that I'm using. So I'm using that intertype font. Source Google means import it from Google Fonts. And then base and headings mean apply it. Base is like the paragraph text, and also apply it there as well as to any headings. So now, if I render this again, it's a little subtle, but hopefully you can see that that is a different font. That is the intertype. It's actually a dark blue now as opposed to the black that it was originally. And that works for an HTML document. It applies to my slides as well. This down here is actually the light blue brand color. And then if you make a website, it will also apply there. So it's great because it can apply across multiple formats. Now, when you make whatever kind of document, you need to share it, right? One way that I often share documents or slides or website is to publish them online. The tool that I like best for this is called Netlify. There are a lot of different options for this. But with Netlify, what you do is you just connect a GitHub repository So you can see here where I'm actually, again, a bit meta, I'm actually connecting the repository that hosts the slides that you're looking at now. So you connect your repository, you set up some deployment options, and then it will push your slides online. So if you actually go to the URL that I gave you before, it's got the slides there. Those are served by Netlify. And the great thing with this approach is anytime you make any changes and you push them to GitHub, the new version of whatever you're doing will show up. Now, I've been talking about HTML files, but you probably at some point have had to make a PDF. So my favorite tool for working with PDFs recently is a tool called Types. The traditional way, of course, of making PDFs is with LaTeX, but Types is kind of a modern reimagining of this. And I think in many ways it's easier, and it's going to become even easier. I know Posit recently announced that they're helping to fund the development of Types. So with Types, we have made documents that look like this. I'm going to show you a quick example of what it looks like, but definitely check out the resources on the artfortherestofus.com/Cascadia 2025, because I gave a talk about this at PositConf last year, where if you're interested, you can see a lot more details. So the basic idea is I set my output format of types in my Quarto document, and then you have two what are called template partials. So types-show and types-template. Types-show is the document, or is the file that passes variables from Quarto to types. So for example, I'm passing the title as a variable that I can then use from Quarto to types, and I'm passing the name of the town. This was a report where we were making parameterized reports, so multiple reports, one for each town in the state of Connecticut. In the types-template, you can see I'm bringing in these variables here, and then I'm setting a bunch of properties. So for example, I want all my text to be Open Sans 12. I want my page to be US letter size with these margins, this background. And then you can see I'm specifying things in the header, in the footer, and we end up with something that looks like this. Next, let's talk about automation. If you can't publish your results online, which I know, obviously if you have things you don't want to share publicly, that might not be the best approach. You can email your reports directly from R. In 2020, we were working with a local organization called Prosper Portland. They're like the small business development agency for the city of Portland. They were giving out grants for organizations as COVID was coming to, they were giving out grants to businesses to help them try to survive. And they were doing that. The grant application happened on a Google form to Google Sheets. We were pulling in that data through the Google Sheets 4 package. And then we were emailing them reports. So we set it up so we could actually email these reports directly from R. We were using the Gmailer package. There's also actually a package called Blastula, which is for sending emails as well. The package we used, Gmailer, our code looked more or less like this. So we were authenticating here on lines 3 and 4. Then we were creating an email report. You can see the to, from, subject, text body, and then we were attaching a file. And then finally, at the bottom, we would send that report. And so we were able to set this up so that they could get a report every day. Now, I just said that we ran this code, but that's actually not totally true. We actually set up this code to run on its own using a thing called GitHub Actions. And I know there's some talks today about GitHub Actions, which is great. So with GitHub Actions, you create a special YAML file that you add into your repository. You push it to GitHub, and it will basically, you can set it up to run code for you. So a simplified version of our YAML file is something like this, where we have a name for it. We have the schedule. So you can see here, this was a cron job. In other words, it was running on a schedule that we set. I forget, that's 14 o'clock GMT. I forget what time that would be exactly, but it was set up so it would run every morning. And then we would you have to tell it to run on an Ubuntu machine, in this case, a Linux machine. We pass some environment variables because we had to authenticate. And then these are the steps we were telling it to run. Check out the repository, install any packages, and then finally run that code in order to send it. So this would run every morning. and the folks we were working with would get a report in their inbox when they started work. Another way that you can automate is to use R to work with files that you actually create from R. So I work every year on a report called Oregon by the Numbers. This is what it looks like. This is just a few pages. It's got like a county by county breakdown of important kind of demographic and other data. I use the FS, zip, and Google Drive packages to get all the assets that I create to the designer, who takes them and compiles them and puts them into the report. For example, I create a ton of PDF pages, again, one for each county. There are 36 counties in Oregon. And then I also am creating all these, what are called these measure pages, which I think there are like 25 or 30 different measures. So it's a lot of files that we create. Using the FS and zip packages, you can see I'm using FS for working with files. I use the dir.ls function to say, what are all the files in that folder? And I save those as county pages. Same thing for the measure pages. Then I use the zip function to zip those up into a single zip file. Finally, I use the Google Drive package, which allows me to connect to Google Drive, to upload them to Google Drive, and then I can just share a link with the designer. Before I had to I would send her all the different PDFs. It was a mess. This is a much, much more efficient workflow. All right, last section I want to talk about is using AI. I'm not an AI hype boy. I'm not going to stand up here and tell you that this model is going to blow your mind or anything like that. In some ways, I'm actually reluctant to talk about this because I feel like AI is changing so quickly that anything I tell you today may be out of date by tomorrow. That said, I think there's some ways that you can use AI that will stand the test of time. The first is to consider creating some custom instructions. So I'm sure probably most people, I would guess in this room, have tried asking ChatGPT or some other large language model R questions. My experience initially was that it would give me sometimes, for example, base R responses, sometimes tidyverse responses. It was a little bit of a mess. What I realized though is if I gave it instructions, that would really help. So now whenever I use a large language model, I'll say this first. Please answer the following R question. When I program, I always like to use the tidyverse. Please don't ever give me base R solutions. And I found that my responses are much better. You can, of course, switch this. If you like base R, just put that you want base R solutions. But just giving those instructions gives you much more coherent responses, I would say. Now, that's a way you can, of course, use AI in ChatGPT or some external place. But you can also use AI directly in your code editor. So GitHub Copilot is a tool for working with large language models. And if you work in RStudio, there's an integration there where you can basically write comments and it will start by actually writing some code for you. It can do other things as well. If you work in Positron, you can't use GitHub Copilot, but there are other extensions you can use. One is called Windsurf. Same basic idea. You write instructions, and then it will kind of take those comments and write some code for you. Now, another thing you might want to do when you're working with AI is you might want to show AI your data. What do I mean by that? I talked with Simon Couch. I don't think Simon's here today, but Simon Couch is a developer at Posit who works on a wide range of R packages. And he told me that data science differs from software engineering in that the state of your R environment is just as important or more so than the contents of your files. What does he mean by this? Well, when you're working with an AI model, it's helpful if it can actually kind of see what your data looks like, see what are the names of the variables, because otherwise it can't write, the code that it will write will not necessarily use the right variable names, for example. So Simon wrote a package called Gander, which helps AI models to have that visibility on your data. So with Gander, you highlight the code that you want to run. There's an RStudio add-in. You ask the question, tell me which schools are within Portland boundaries. You tell it where to give you the response. It will write that code. It looks kind of similar to GitHub Copilot. But behind the scenes, what it's actually doing is it has system instructions. So it's saying, you are a helpful but terse R data scientist, respond only with valid R code, etc. It's also then passing information about your environment. Well, first it's passing your code. Up until this point, the contents of my file reads this. Now, and you can see this is the question I asked. Write me code to tell me which schools are within Portland boundaries. But then it also passes information about the objects in your environment. So Portland boundaries and PPS elementary schools, so that the AI model actually can see what your data looks like and write better code as a result. All right, last section is to use AI for data analysis. Be careful with this. I would not use this for anything mission critical, and I would especially urge you to review whatever results you get. But I think there's some interesting ways that you can use AI for data analysis, in particular with qualitative data. There's a package called MAL, which provides some nice out-of-the-box functions for working with qualitative data using AI models. So for example, you can translate text. I brought in some data from our community survey that Posit did several years ago that's looking at this question is, what do people like best about R? So some of the responses are in Spanish. With MAL, you can use the LLM translate function, and you can actually automatically translate data from, in this case, Spanish to English or any language. You can also use MAL to summarize text. So I'm using the LLM summarize function here to take the longer responses in the English column and summarize them down. Now, these responses aren't that long, but imagine if you have like a couple paragraphs, this can provide a really nice way to summarize. Those functions come from the MAL package, and they're kind of like built in, like built for you. Sometimes you want to create your own prompt. If you want to do that, the Elmer package is a great tool. I've used Elmer package in this way, where I've created my own function called identify themes. You're a sociologist looking for the top 3 themes and responses to a survey. Each response is separated by the new line. And so this will actually take a long chunk of text and summarize it, identify those themes. So I'm going to take the English responses, I'm going to collapse them like that, so my data looks like this. And then I say survey translator combined and identify themes. And what I get back is something that looks like this, which is not too bad. Okay, I've now given you 24 things that you perhaps didn't know that you could do with R. All of them are technical, but I'd be remiss if I didn't mention the one thing that you can do with R that is in fact the opposite of technical. When I started learning R, I never expected to find such a strong and welcoming community, but that's exactly what I found. R has technical power, sure, but R also has the ability to bring a wide range of people together on a Saturday to sit all day in an air-conditioned room. You may not have ever considered it, but R can help you to find your community. And as you learn from others today, I hope that you'll consider giving back to maintain and improve the wonderful R community that we all gain so much from. That I, as a qualitative researcher, who for so long thought of myself as not being a real R user, am up here today, is in no small part because of the encouragement I've received over the years from the R community. It may be a technical tool that brings us together in the first place, but it's the community that will keep us together in the long run. Thank you.